Hello guys, good morning. Looks like we're missing a lot of people, so probably we're gonna wait for a few more minutes and then we'll start again. We'll start the course. So next week is gonna be the study week, so we don't have any class anymore. So you can basically take your time and go through the material of the course and prepare yourself for the next exam, which is gonna be test 2, which is gonna be mid-March. So how are you guys doing so far? Is that good? You're good with the class? You catch up with the class and courses? Everything is good? Yes? No? Yes?
Yeah. May I ask? Since you recorded, I realized since you record the lesson. Where do I find them? Where do I find the recordings?
So you can go just to Zoom and your Zoom account. You can find it in the Zoom account. Also, I post the Zoom links in the basically in my in the Blackboard shell. I post basically the Zoom link for all the courses which you have before.
Yeah.
You can find it on basically you go to course shell.
Yeah, because I am on week just a sec.
Yeah, so let me just.
I'll go to like week 4, like week 4 and.
No, yeah, it's let me just show you here, okay? I'm just gonna share my screen, okay? Share my screen here, okay? Now you can see my screen, and then you go to content. I'm just gonna do it as. Oops, sorry. You go to content into student preview, and then you basically see Zoom, yeah. And then this is links. I put 3 links for the first 3 weeks, but I need to update it to add the other link, the other weeks, which are this week. So basically this week and 2 other weeks last week. So this is only the first 3 weeks. So the first 4 weeks, because the first week we didn't have. So first 4 week and 2 more weeks I need to put up the recording link. So so you just click on that, and then you will see basically you go to basically Zoom meeting recorded. Okay. You got it, Vivian? Hello? Yes? No? Yes?
Yeah, I'm sure. Yes.
All right. Good. All right. Yeah. Just go to Zoom virtual class on Wednesday, and then Zoom recorded links. So these are basically recording, and there are passcodes basically. So probably need to add the passcodes. So yeah.
Yes.
All right, so I'm gonna start. Okay, so I appreciate if one of you guys just keep an eye on the participants. If someone joined and try to join, because when I go to full screen mode, I can't see anyone in the lobby. So I appreciate if one of you guys keep an eye on the participant. If someone is in the lobby, let me know so that I can let them in. Okay, thank you guys. All right, let's start with the course today. We're gonna continue to talk about annuity, right? So we discussed last week about the ordinary simple annuity, right? So this week we're gonna talk about ordinary general, do general, and do simple annuity. So we're gonna cover the other three type of annuity, right? So that's what we're gonna do this week, okay? So let's start with ordinary general annuity. In an ordinary general annuity, payments are made at the end of each payment period, and the compounding period is not equal to the payment period. Okay, so we learned what was the ordinary simple, right? Ordinary simple, the payment are made at the end of each month or in the end of each payment period, and also the compounding period was equal to payment period, right? That was compounding month, like compounding with the company monthly and you pay monthly, compounding bi-weekly and you pay bi-weekly, you compounding semi-annually, you pay semi-annually, right? So with when basically the the compounding period is equal to payment period, then that's going to be simple annuity. Okay. So when the compounding period is not equal the payment period, it's called general annuity. Okay. And then since the payment are made at the end of each payment period is going to be ordinary, right? So we have ordinary and we have due. Due is the due annuity is annuity that the payment made at the beginning of each payment period. Okay. So how can we tackle the problem of general annuity? The only thing which we need to do is just convert this the interest rate, which is compounding the compounding period is different than the payment period, to an interest rate which compounding period is equal to payment period. And how can we do it? We're using this equation. So basically you find C, which is number of compounding period per year, divide by number of payment period per year, and then we use this equation to find I2, which is equivalent. You see, you remember we discussed the equivalent interest rate. We find equivalent interest rate to the interest rate which is the compounding period is different than our payment period, and we find equivalent interest rate which has the same payment period as which has the same compounding period which is the same as payment period. So I2 is going to be 1 plus I power of C minus 1. So, and with this, we convert the interest rate, which the compounding frequency is different than our payment frequency, to a interest rate, which basically compounding frequency is equal to our payment frequency. So that's only this equation. With this equation, we convert that, and after that, the rest is going to be the same, right? So basically, we can calculate the equivalent periodic rate I2 that matches the payment period, and use the ordinary simple annuity formula to calculate future and present value. So that's the only thing which we need to do for ordinary general annuity. Find a new I2 which is equivalent to I, which has different compounding frequency than our payment frequency, and then after that uses I2 to calculate basically the future value and present value of annuity. So future value is going to be PMT 1 plus I2 power of n minus 1 divided by I2, and present value is going to be PMT 1 minus 1 plus I2 power of minus n divided by I2. So basically, the only thing which we need to do for ordinary general annuity is just calculate the I2, which is going to be 1 plus I power of C, as we say here, I power of C minus 1. And C is number of compounding period per year, like compounding frequency for your interest rate, divided by number of payment per year. Compounding frequency divided by number of payment per year. Just remember this: compounding frequency divided by number of payment per year. Okay, and then the rest is going to be the same. So which of the following statements best describe an ordinary general annuity? Payments are made at the end of the period. This is basically ordinary, and the compounding period is different from the payment period. That's right. That's the first one, right? So the first one is going to be ordinary general. Payments are made at the end of the period. This is going to be ordinary again, and the compounding period is the same as the payment period. This is going to be simple, ordinary simple, right? C, the payments are made at the beginning of the period. So this is due, and the compounding period is the same as the payment period. Simple, due, simple, right? And D, payment are made at the beginning of the period, which is due, and the compounding period is different. So that's going to be due general, right? So the ordinary general payment are made at the end of the period, and the compounding period is different than the payment period. Okay. All right. Lily saved $250 every month in an account that was earning 6% compounding quarterly for 2 years. What was the accumulated value of her investment at the end of the term? Okay, when it doesn't say when the payment date or end or beginning is not stated in the equation. When it doesn't say that they pay every month, it's assumed that's at the end of the period. Okay, When it doesn't say every month, it's a really safe 250 every month. It doesn't say there is a beginning or end of the month. We always assume it's the end of the month. So unless it says every beginning of every month, then it's going to be do. When it doesn't say, we presume it's going to be ordinary. Okay. So now solve this question. So it's 6. Okay. So first of all, we need to find which kind of annuity it is. Okay. Every month, which means at the end of every month, which is going to be ordinary. And then the interest rate is 6% compounded quarterly, but she has spent every month, right? So this is not compounded monthly. If it's compounded monthly, then they spend every month. That's going to be simple, right? But this is compounded quarterly. So interest rate compounded quarterly, but pay every month. So it means that the annuity is general, right? So because the interest rate compounded period is different than your payment period, right? So it's going to be ordinary because payment made at the end of every month, and general because the compounding frequency is different than payment frequency. Okay. And so how we solve it, as we said, we need to change. We need to find I first, and then I2. So we need to find I2, right? So let's so we want to find future value for this, right? So how we do it? So first of all, let's find I first, right? We find I is equal to basically the J divided by M, which is compounding frequency, right? So it's going to be 0.015 per quarter. And now we find C. Yeah, C is going to be compounding frequency, which is going to be this compounding frequency divided by number of payment per year. So compounding frequency, which is 4 because compounding quarterly, right? Divided by number of payment per year, which is 12. So we find C, and now we use this equation to solve that. Let's solve. Let's find I2. Okay, we did with our calculator. Let me first see. No one. Yeah, someone is in lobby. Let them in. All right. Let me go to. Oops, sorry. Let me go to my calculator. All right. So we want to calculate this, right? So we're going to calculate this, right? 1 plus 0.015 is going to be 1.015, right? So 1.015 is going to be the base, right? So store at number 1, and what's the basically power? 4 by 12. 4 divided by 12 equal to store number 2, and now you have number 1, recall number 1, power of recall number 2 equal to -1, right? This power of this -1. So it's going to be this number, right? So yeah, this number per month. So now we find I2, okay? And now you need to use the equation for future value. So what's N? N is going to be, so basically N is going to be total number of payments, right? So total number of payments is going to be, the total number of payments is going to be total number of payment per year, which is going to be, which is 12, right? So 12 because you pay every month, right? So 12 multiplied by number of years, which is 24, right? So N is always basically total number of payments. So okay, you don't forget that, okay? So it's going to be total number of payment per year multiplied by number of years, okay? So that's going to be this, and let's do this also together again. So we don't remove this from calculator. We need to add it +1 power of 24, right? +1 equal to this. So this is going to be inside this power of 24. Power of 24 equal to, and then -1 equal to, okay, and then divided by this number. Sorry, I need to save that at the beginning, but it's fine. So 0.004, 0.004, 975 equal to this. So this is going to be this. The whole thing is going to be this. and had to be multiplied by 250 equal to this 6,356. Okay. All right. So that's going to be total investment. So 250 every month in that account for 2 years. Yeah. Any question? Any question here? All right. So the strategy is pretty simple, right? So you basically the only thing which you do in addition of ordinary simple, you just find this I2, right? So you need to just find I2 and then use I2 for your equation when you are ordinarily general. And how do you find I2? I2 is got to by 1 plus I power of C minus 1. And what is C? C is basically, C is the compounding frequency. Like here, in this case, compounding frequency is 4 because your interest rate is compounded quarterly, right? 4 divided by number of payment per year, which is going to be 12, right? Number of payment per year. So this is 4 divided by number of payment per year. So that's C. And then now you find I2. So first of all, you need to find I first, right? So because this is J. This is J. You need to find I. And then use I2. And then after you find I2, you go use the equation for future value to find the total investment. Okay. Any question? All right, no question. We're gonna use this calculator for this. So using calculator is even more fun. Okay. So now let's do calculator. The calculator now we use, when you use calculator, that the P over Y and C over Y now is different, right? So the only thing which is different in the calculator, now you can use P over Y or and C over Y. You need to set them differently. Before that, we set P over Y equal to whatever, and C over Y was automatically equal to that. Okay, but now in calculator we need to, the P over Y is number of payment per year, and C over Y is number of compounding, is the compounding frequency basically. Number of payment per year, compounding frequency. Okay, so that's the only thing which is different. So let's do it in calculator. Okay. So let me just clear everything here, and then clear work, clear everything. Okay. $250 every month. So first of all, it's ordinary general, right? So ordinary general. So 250. So ordinary general means it has to be end, right? Second begin has to be end. Okay. Second quit. Okay. So make sure you're always at the end. Okay. So it means the payment are done at the end. Okay. That's important. Payment done at the end. Okay. And then in there every month. Okay. So that's ordinary. And now 250 every month, 250 negative sign payment, right? 0 is present value. Yeah. 6% compounded quarterly, 6% this, and total number of payments is going to be 24, right? 2 years, 12 months, total number of payment and 24. So now the only thing which you need to set is P over Y and C over Y. P over Y payment per year. How many payment per year you have? You have 12 payment per year. It's monthly, right? And now you go shift arrow down, key down. C over Y is automatically set to P over Y. But now in this case, it's different, right? Because compounding frequency is 4, right? Compounding frequency for the interest rate is 4. 4. And now we quit. And now CPT future value. Okay. So it'll give you 6,314. Yeah. It's very simple, right? So the whole thing is very similar to ordinary simple interest rate, simple basically annuity. The only thing which is different is you set the payment P over Y and C over Y differently. Okay. So I'll go once again. P over Y is 12 because number of payment per year is 12, but C over Y is 4, right? Because it's compounded quarterly. Yeah, interest rate is compounded quarterly. So it means since compounding frequency is going to be 4. Okay, and then quit. Okay. Any question here? No question. Let me see if there is anyone in the
Professor, can I know how to set the N mode once again, please?
Oh yeah, so so end mode. Right. So let's go there. So second begin, second PMT, second PMT begin. Okay,
Okay.
that's when you set that. So it's set end. Okay, and if you want to change it, if you have do annuity, you do second enter. It's become
Is it
begin.
okay?
It's
Is it
become begin.
sorry? Is it necessary to every time set it begin or end for
No,
calculating?
it's no default is end. Default is end. Default is end.
Okay.
And if you do set begin and then you quit, and then you see the top and on your calculator it says BGN, right?
Okay.
BGN. That means you're working with do annuity.
Oh,
Yeah, the BGN, small BGN you see up there.
yeah, 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 Professor. I can.
So you can just go there again. Second, when you do second begin, it become begin, okay? And then you change it. Second enter, become end, and then quit. Yeah. When it's end, there is nothing show you in the calculator because in default will think that's the end is like
Okay.
ordinary annuity. Okay.
Yeah. Professor, one more question that
Yeah.
I found calculator more easier than using the formulas, but
Okay.
is it necessary to learn the formulas?
If you're comfortable with calculator, I would say no, but I don't know. It's just up to you. So
Like
yeah,
for the exam, is it
no, you can use calculator for exam as well, right?
okay? Thank you.
Yeah, you're welcome. Right.
Professor, how do we set it to, I'm sorry to interrupt, to
Yeah.
beginning?
Begin. So second PMT, right? This become end. Now second enter.
Okay,
And second enter again
thanks.
and second enter, second enter, second enter, second enter. See? You can play with that. After you happy with the end, second quit. Yeah. So second begin, second enter. Second set basically begin, second set. Yeah, something like that. Yeah. You got it? All right. All right, so let's go for the another example. This one you guys have to do it yourself, okay? You have 5 minutes for this. John requires a student loan but can afford to pay only 850 per month for 5 years toward the repayment of the loan. How much would the bank give him if they charge an interest rate of 7.2% compound annually on a student loan? Okay, so this is basically present value problem, right? So they give him the loan. Okay, yeah, for 5 minutes for this as well. All right. All right, let's see what you guys did here. Okay, you got a lot of B. Yeah, 2B, okay. Oh. All right, and see, yes, B is right. All right, let's solve it and then see, okay, so which kind of annuity is this? Is ordinary because the payment is paid per month and it doesn't say whether beginning or end. When it doesn't say in the question whether beginning or end means end, okay? So it's ordinary. And general, why? Because the 7.2% compound annually, right? But he's paying per month. So the compounding period is different than the payment period, okay? So compound annually, paying per month. So that's general, okay? Now we have to use the equation for general, right? So it means we have to use I2 equal to 1 plus I power of C minus 1, right? So first of all, we need to find I, we need to find C, and we need to find N. So N, first of all, N, let's see, let's first of all, first find N. N is going to be number of payment per year multiplied by number of years. So number of payment per year is going to be 12 multiplied by number of years. It's going to be 5. It's going to be 60. Now we're going to find I first. I is going to be J divided by M. J is 7.2 divided by M compounding frequency. Compounding frequency in this case is 1, right? Because it's compounded annually, right? So 1, so it's going to be this. And now we want to find I2. Sorry, C. So first of all, I2. I2 is going to be 1 plus I power of C minus 1, right? So find C. C is the number of compounding per year divided by number of payment per year, right? So number of compounding frequency per year is basically compounding frequency divided by number of payment per year, okay? Compounding frequency in this case is 1 divided by number of payment per year is 12, right? 1 over 12. So now we have this, and we can use calculator for this. So I'm not gonna do that now because we already know how to do it. And now so this is gonna be I2, and now we so we have to use the present value equation, right? Present value is PMT 1 minus 1 plus I2 power of minus n divided by I2. So it's going to be this. So let's do this together. This is a little bit more complicated than the other one. Let's do this together. Calculator. 1 plus. So first of all, we want to calculate this thing. Okay, the one inside the big parentheses. We want to do that. So first of all, we need to do a small parentheses here. So 1 plus 0.005810 power of minus 60. Okay, so 1 plus 1.005810 005810 power of minus 60 power of 60 negative equal to this one. Okay, now 1 minus this number. Okay, 1 minus, so you have to store this number at 1 minus, we call 1, right? So it's going to be this number divided by 0.05810 divided by 0.005810 equal to, and then multiply by 850. Multiply by 850. So it's going to be this number, 42,955. So the problem is a little different than what you have there because you had the rounding problem. Now you see here, this guy, we rounded to 4-digit, 5810, but this is more number there, but we haven't used them, okay? That's why we have something a little bit different. So don't worry about it. Just use the answer which is closest to the number which you find, okay? Use that answer, okay? Now, if you want to use calculator, which is much easier, as you said, it's much easier to use calculator. You just use clear everything, and now you go there. 850 per month, so it's going to be 850 negative payment, yeah. And now total number of payments is okay. So let's do the other one. 7.2% compounded annually, so 7.2%. This guy, total number of payments, 5 multiplied by 12, right? So 12, pay every month for 5 years. 12 multiplied by 5, which is going to be 60, right? So 60 is going to be total number of payment. And now the only thing which you need to set, so future values in this case is 0. To make sure you put future value is 0 because we want to find the present value. And now you go to this mode, P over Y and C over Y. P over Y payment per month is every month, so it's 12. That's fine. And the C over Y is compounded annually. So C over Y is 1. It's going to be 1, right? 1, yeah. And then I quit. And now we have set everything now. So you just need CPT PV. 42,944. Okay. So with calculator, as she said, it's very much easier to use calculator, but just make sure that you set everything right. So yeah, there's no, basically there's nothing hold you back from using the calculator. But sometimes the questions are not easy to use calculator. Sometimes question has 2 parts, and still you can use calculator. But yeah, sometimes a question is tricky. Question can be tricky. So that's why it's sometimes hard. But if you're comfortable using calculator, right, there's nothing can basically hold against it. So you can use it basically. All right, so that was ordinary general. We will go to do annuity. So any question until now, guys? Any question before we move to do annuity?
Not really.
All right, thank you. All right, so let's do simple do annuity. All right, so future value and present value of a simple do annuity. Okay, so again, let's go to the simple questions here. So which statement best describe a simple do annuity or annuity do? Okay, so payment are made at the end of the period, and the compounding period is different than the payment. Payment paid at the end of the period means this is ordinary, right? So this is not due. Payment are made at the beginning of the period, so this is due, and the compounding period is different than the payment period. That's general due and the general, right? So it's not simple due, right? So payment are made at the beginning of the period, which is due, and the compounding period is the same as the payment period. This is due simple, so this is the one, right? Payment are made at the end of the period, and so this is going to be ordinary, and the compounding period is the same as payment period. Ordinary is simple. So this is C. The C is right answer. Okay. All right. How do we calculate the future value of the simple do annuity? Okay. So the only thing which is different from basically do annuity and the ordinary annuity is the payment, instead of being at the end of each payment period, is going to be at the beginning of each payment period. So it means that we only have one payment period interest added to everything, right? So instead of payment being starting at this month and you accumulate the interest, you started at the beginning and you accumulate interest. So you have 1 month or one basically payment period of additional interest. So that means your equation is going to be another term of 1 plus I added to it. So basically your equation for future value for do annuity has another 1 plus I added to whole thing, to everything. To everything you have to multiply 1 plus I. Okay, so it means that you have an additional months of the interest. So that's basically the whole equation for future value for do annuity. So basically that's the equation for simple annuity. Basically it was the equation for ordinary annuity. Just you need to add a 1 plus I in front of it to take into account that the annuity is due. So you have to have 1 month, an additional 1 month interest, basically. So an additional 1 month interest is considered 1 plus I. Okay, that's basically how we calculate the due annuity. So in a due annuity, as each payment is made at the beginning of the payment period, you will notice that the future value accumulated of the each payment is the multiple of the future value of each payment in an ordinary annuity by a factor of 1 plus I. So that's the only thing which is different than the dual annuity and the simple annuity. It's just a factor of 1 plus I in front of each payment, right? Here you have each payment multiplied by 1 plus I. If 1 plus I basically added to each of the payment, because you started from beginning of the month instead of end of the month. So you have an additional 1 month of the interest, which is going to be 1 plus I. So basically that's why you'll have this factor of 1 plus I in front of future value of the ordinary simple annuity. So if you have an ordinary simple annuity, just multiply 1 plus I, we can do simple annuity. Yes. So ordinary simple 1 plus I is going to be do simple annuity. Okay. All right. So let's do an example. Any question here, guys? It's pretty simple, though, right? So to do simple annuity, use ordinary simple equation multiplied by 1 plus I factor. All right, so Martha makes contribution of $350 at the beginning of every month, every 6 months for 8 years. So beginning of every 6 months for 8 years toward an RRSP. If the RRSP earns interest at 5.6% compounded semi-annually, what would be the value of RRSP at the end of the period? Okay, so first of all, we need to recognize which kind of annuity it is. Okay, beginning of every 6 months. As soon as it say beginning, it's going to be due. Okay. So now see whether it's general or simple. So you pay every 6 months, right? So you pay every semi-annually, okay? Pay every 6 months. And the interest rate is compounded semi-annually. So interest rate semi-annually, and she pay every 6 months. So semi-annually. So semi-annually means simple. So do, which is beginning, and simple. So you need to use do simple equation, okay? And then okay, so let's do it. So do simple. We have so first of all, we need to find what's n. N is going to be basically number of payments per year. Total number of payments. So total number of payment is going to be number of payment per year, which is m, multiplied by the number of years. So how many payment per year we have? We have 2 payment per year, right? So 2 6 months is going to be 12 months. 2 payment per year multiplied by 8 years, 16 payments. And now we find I. So what I is going to be J divided by M. I is J, 5.6 divided by M, the compounding frequency. Compounding frequency in this case is 2. So it's going to be 2. And then you got this. And now we use the equation for future value for a do simple annuity. So which is the equation for ordinary simple multiple of 1 plus I. Okay, so 1 plus I power n minus 1 divided by I is going to be this guy. So okay. So do you want this together in the calculator as well? Let's do this in the calculator as well together. Okay, so this thing in calculator. Okay, so first of all, we need to. We can do 2 approach. Okay, we can basically, first of all, we need to find the thing which is inside this. Okay, this is the most complicated one, and then we start with the most interior one, which is going to be 1 plus 0.0028 power of 16. So let's do that. 1 plus, so 1.0228 power of 16, 1.028 power of 16. Okay, equal to minus 1 equal to, so that's going to be the denominator for this, divided by 0.028 divided by 0.028 equal to, so that's going to be this, the whole thing inside. So okay, so I'm going to store this at number 1. Okay, now so now I have 1 plus 0.28. Okay, so 1.0028. Okay, so this is this guy. It's going to be multiplied by this guy, multiplied by whatever I recall it in number 1. It's going to be this one, and then multiply by 350. Multiply by 350 equal to 7,139. Yeah. So that's how we calculate the future value for basically do simple annuity. Okay. Any question?
Yes. Isn't that 6.5 years? Oh, it's times 8. So yeah, 16.
Yes.
Yeah, half yearly payment.
Yeah, the total number of payments, right? N is going to be total number of payments. How many payments we have? How many payment per year we have? We have 2 payments per year, right? Because we pay every 6 months. We're not paying every month. We're paying every 6 months, right? So we have 2 payments per year. 2 payments per year multiplied by 8 years. So it's going to be 16 payments.
Yes.
Yeah. N
Yep.
is total number of payments. Total number of payments. Okay. So 16 payments. Yeah. Did you understand? Yeah. All right. So okay. So okay. Now let's do it in the calculator. Okay. All right. So Martha makes a contribution of $350 at the beginning of each 6 months. So as I said, it is simple do annuity, right? So do simple annuity, right? So beginning of each month. So let's go to the calculator. Let's see first. No one is in lobby. No one is in lobby. All right. All right. So let me clear everything here. Calculator. Okay. So it is basically, sorry guys. So it is basically beginning of the everything. So I have to set the calculator to beginning, right? Second, this is end. Set. Quit. So now it's on the beginning mode, right? BGN is on top, right? So it's on begin mode. So now I go for put this stuff there, right? So 350 every 6 months. So $350 negative payment, yeah. And then we have 5.6% compound semi-annually. 5.6% I over Y. N is going to be, as I said, N is going to be 2 multiplied by 8, right? 16, because every 2 payment per year. So 16 is going to be N. So I said PMT, I said this. We want to find future value, right? The value of the heuristic at the end of okay. So we want to find future value. So present value is 0. Make sure you set present value is 0. Now we have to set the P over Y and C over Y. P over Y in this case is section P over Y. P over Y in this case is 2, right? So compounding frequency. 2 payment per year, right? Payment per year. 2 payment per year. And C over Y is basically compounding semi-annually. Compounding frequency is 2, right? So 2 is 2. It's already set. 2, and then quit. Okay. So now everything's set. We need to find what's the future value. 7,139. Okay. Yeah. Yeah. Any question? All right. All right. So what's going to be the present value of a simple do annuity? Okay. So we find the equation for future value for simple do annuity. But what's the present value? The present value is going to be very similar to basically very similar to ordinary simple annuity. Again, you have only 1 plus I factor in front of it. Okay. So what happened here is again exactly the same thing. So you shift everything 1 month, 1 month basically. So in advance. So when you shift it back, so you have to basically you have to 1 plus I factor is still multiplied by all of your payments. So basically it means that you have 1 plus I in front of it. So basically the equation is going to be the same as present value of an ordinary simple annuity, with the 1 plus I factor. So do annuity, just keep in mind, do annuity equation, you need to just multiply 1 plus I for both future value and the present value and the equation. So present value for do annuity, do simple annuity is going to be PMT 1 minus 1 plus I power of minus n divided by I multiplied by 1 plus I. Okay. So that 1 plus I factor is always there. Okay. Yeah. So that's just going to be the equation for that. So, all right, I'll give you 5 minutes for this as well. What's the present value of annuity that pays 28.50 at the beginning of every 3 months for 5 years, assuming the interest rate is 8% compound quarterly? I'll give you 5 minutes for this as well. Okay. All right, let's see what's the answer. So the other A, I hope the A is right. See. All right, A is right. Yeah, congratulations to you guys. All right, so first of all, we need to find which kind of annuity it is, right? So what's the present value of the annuity that pays at the beginning of every 3 months? Beginning means a due annuity, right? And then let's see, is it simple or general? So every 3 months, so it means it's paid every quarterly, right? Paid every quarterly, and the interest rate is 8% compounded quarterly. So interest rate compounded quarterly, and then it paid quarterly every 3 months, right? So it means it's simple, right? Simple annuity, because the interest rate compounding period is equal to payment period. Okay, so simple due annuity. So we need to use the equation for simple due annuity, which is going to be present value is equal to PMT 1 minus 1 plus I power of minus n divided by I multiplied by 1 plus I, right? So all right, so first of all, let's find the thing which we need here. What we need is we need n, total number of payment. It's going to be, you pay every 3 months for 5 years. So total number of payment is going to be, the total number of payment is going to be number of payment per year. It's going to be 4 payment per year, right? So you paid every 3 months, so 4 payment per year. Low compounding frequency, or compounding frequency is going to be 4. Multiplied by total number of year, it's going to be 5, so it's going to be 20 payments. Okay, now let's find I is going to be J 8 divided by M, which is this compounding frequency, right? So J divided by 4, right? Compounding frequency. So it's going to be this, I is going to be this, and now we need to use the equation for present value for due annuity, which is going to be present value for simple annuity multiply by 1 plus I, right? So it's going to be present value for ordinary annuity multiplied by 1 plus I, okay? And now I just need to put the stuff in there in this. So you need to put all this stuff which you calculated here in this equation. So PMT is 2085, okay? I is here 0.002, and N is 20, and then this, okay? So now we have to calculate this guy, okay? Let's calculate this guy together, okay? So 1 plus 0.002, which will become 1.02, right? So 1 plus this guy, 1 plus 0.02 is equal to 1.02, right? So 1 is going to be add to 0, right? So 1.02 power of minus 20, power of 20 negative, yeah, equal to. So this is this number, right? We want to 1 minus this number. So we store this number to 1 minus recall 1. Okay, so it's going to be the denominator here divided by 0.02 divided by 0.02 equal to. So that's going to be this guy. Okay, so that's going to be the whole thing, 16. This guy. Okay. Now we can store this at number 1. Okay, store at number 1. So okay, so you just store this the whole thing at number 1. So 1.02 multiplied by recall number 1 equal to this, and then this is this combination. You have to multiply by 2850. Multiply by 2850 equal to 47,533. Yeah. So that's going to be the final answer. Okay. Okay. And now, if you want to use calculator, which I think some of you guys, I think the guys who are answering right, I think they're mostly using calculator, but it's fine. So, so as we use calculator, let's do that in calculator. So let's clear everything, Set the calculator to begin. It's already on begin, right? But I'm just gonna do it again. Set it again. So second PMT is begin, okay? Second quit. So it's already in begin, okay? Because it's do annuity is simple, okay? And then payment 2850, 2850 negative payment. We want to find the future. We want to find the present value, right? So future value is 0, yeah. And I over y is 8%, so 8% is I over y. And how many payments we have per year? We have 5 years multiplied by 4 payments per year, so 20, right? Am I right? Yes, 20. And it's going to be 20. So why is it n equal to 8 here? That's a mistake, right? It's a mistake in the PowerPoint, so I have to report it to the people, right? So 20. And now we want to know what's the I over y and p over y and c over y, right? So it's going to be 4, right? So there, payment per year is going to be 4 payment per year, right? So every 3 months, 4 payment per year. And c over y compounding frequency is going to be 4 as well. So that's right. And then we come out. Now we set everything. We just need to find what's the present value. 47,533. Yeah. So this is not right in the calculator. It has to be 20. Yeah. Let me just fix it here. Where is that? Oh, all right. Anyway, okay. I can fix it here. Anyway, yeah. All right. Yeah. All right. So a lease present. So what's a lease? A lease present an alternative of obtaining a loan to purchase an asset. With the lease makes regular payment to essentially borrow an asset from the lessors. Through the term of the lease does not own the asset during or after the term. The owner should remain with the lessors. Okay, so lease is different than the than annuity, kind of. Lease basically is similar to annuity. The only thing which is different than the lease and the finance is that the whoever leases the car or whatever you have there, at the end of the lease period, the car is going to come back to the someone who's leasing the car or the asset. Okay, so but the equation is going to be the same, right? So the equation for the lease and the duality is going to be the same. Okay. All right. So a car dealership provided Stephanie with the following 2 options. Buy option, pay $51,500 immediately to own the vehicle. Lease option, make a down payment of $27,500 and lease payment $930 at the beginning of every month for 2 years. For 2 years. At the end of the 2 years, she has the option to buy the vehicle for the residual value of $19,000. The cost of borrowing is 3% compounded monthly. Which option is cheaper? Okay. So you have 2 options, right? So here is basically she has 2 options. One option is just to buy for $51,500. The second option is you pay this at the beginning, and then the lease payment, which is basically due. This is the due. Basically simple, right? So due because it's at the beginning of every month, and simple because it's the interest rate is compounded monthly, and the payment has been made every month, right? So basically it's simple. Do simple annuity, right? So it said which option is cheaper. So we have to find the present value of this annuity, okay? But at the end, you have also $19,000 as basically residual value that she has to pay at the end of the lease period, okay? So we need to basically also find the present value for that $19,000, right? So we have this guy, okay? We have a due annuity, which you need to find the present value for that. Okay, so to add to this guy, right? So present value for that for annuity we add to this, and also you have 19,000 after 2 years, right? So we want to know what's the value of 19,000 after 2 years at present value. We want to know what's the value of the 19,000 at the present value, then added to the whole thing, added to this 27,000 and added to also to present value of the annuity, right? So, and then then we compare it with 51,000, see which one is cheaper. Okay, you understand this? So basically, we have a down payment, 27,500. We have an annuity, okay, which we need to find the present value for that, right? So present value for the annuity, which is going to be added to down payment. And also we have 19,000 after 2 years. We want to know what's the present value of that 19,000 after 2 years. So that's the future value. 19,000. We want to pay 19,000 after 2 years, but we want to know what's the present value of that if the interest is 3% compounded monthly. So we have to add these three numbers together and then compare them with 51,000. See which one is cheaper. Okay, which one is cheaper? So that's then we basically we can say which one is better options. Okay. Do you understand this question, guys? Yeah. All right. Okay. So basically, there is annuity calculation which is simple do, and there is also a present value calculation which be the regular investment. So you need to use the present value equation, like the basically regular investment present value. Okay. So let's first of all find the parameter for this. Okay, for the annuity. Okay. So the number of payment is 12 per year and for 2 years, right? So then basically 24 is going to be number of payment, and now we use this equation for present value for simple do annuity, right? So that's going to be this. So what's the I? I is going to be 3 divided by 12, right? So it's going to be 0.0025, right? So so let's calculate this in the calculator together. I just want to do it many times so that you guys become familiar to calculate this kind of equations. Okay, so let's do it together. So 1 plus 0.0025 is going to be 1.0025 power minus 24. Okay, so 1.0025 power of 24 negative equal to, yes, and then 1 minus this guy. So it's store this at number 1. 1 minus, recall 1 equal to this guy divided by, so this is the denominator. This thing is denominator here, denominator. Divided by 0.0025 divided by 0.0025 by this guy. So 23. This is going to be this. Okay, and this is going to be multiplied by 1.0025 multiplied by 1.0025 equal to this. And now we have this two together. Now we multiply by 930. Multiply by 930 equal to, so 21,691. Okay, so I'm gonna store this as the 1. Okay, so 21,691. Okay, that's present value for due annuity, right? So basically, the lease payment that we paid, that Stephanie paid for 2 years, $930 at the beginning of every month. The present value for that is going to be 21,691. Okay. Now we need to find another present value, right? We need to find the present value for $19,000 as well, right? So 19,000 in 2 years. We want to know how much is the value of other 19,000 today, not in 2 years from now. Okay, so we need to use the regular investment present value versus future value equation. So present value is going to be future value 1 plus I minus n, right? So it was future value was present value 1 plus I power, and now that's the other way. Now you put the equation there and we calculate, and it's going to be 17,894. So 17,894 is a present value for that $19,000 in 2 years. Okay. And now we have to add down payment plus lease plus residual. Okay. So we add this three together. So it's going to be 67,000. So $67,000 is going to be a present value for the lease, while she can just pay 51,500 and then don't do that. So definitely it's always like this, right? So if you pay for your car when you buy it in cash, definitely it's going to be much cheaper than you go to release and down payment and all those things, right? That's how the car dealerships and banks are making money, right? So they basically give you loan and they give you twice as much. You have to pay them twice as much and 1.5 times as much for just having the car. Okay, so that's basically it. And then if you wanna do it in the calculator way, let's do it in calculator way as well. Any question? Any question here, guys? Any question?
If we use the other option to calculate this one, how can we do that? Because I try use the NIV. Yeah, this one. I cannot do
the calculator. Okay, so let's do that. Okay, before that, there was another question to it. Someone else was asking a question.
How did you get 2 the I 0.025?
I is going to be 3 divided by 12, right? 3 divided by 12. 3 divided by 12, right? 3 compounded monthly. 3 divided by is J divided by compounding frequency, right? This is J, right? J divided by compounding frequency is 12, right? 3 divided by 12. 3 divided by 12 equal to this
0.25.
But this is percent, right? Divided by 100. Percent, right? It's
Okay.
percent. It's percent, right? 3 divided by 12, but it's a percent divided by 100, right? Yeah? Yeah? You got it?
Yes.
Yeah. So 3%, 3% divided by 100, right? First already, and then divided by 12. All right, so yeah, let's go the calculator way, because some of you guys are more interested in the calculator way. You guys make your life much easier, right? So that's fine. That's as long as you know how to do it in calculator, that's fine. So payment of 930 at the beginning of every month for 2 years, right? So 930. So let's clear everything here. Make sure it's at the beginning. So second PMT is at begin, yeah, because it's a due annuity, right? Beginning. So 930 payment here. And now we want to find the present value, right? So future value is 0. Yeah. So I over Y is 3%. So 3% is going to be this. And then N is going to be, okay, N is going to be, so 2 years for every month, right? 2 years every month is going to be 12 multiplied by 2, 24. 24 this. And now we need to go to P over Y. P over Y, 12, right? Every month, and this component monthly. So 12 is going to be P over Y. C over Y is going to be equal to P over Y because component monthly, right? So, and quit. Now we set everything CPT PB 21,691. Okay. So 21,691 is going to be basically the
Professor, but it's showing the future value is minus 19,000. Do we have to fill in the calculator?
Oh yeah, so okay, that's a good question. So now in the calculator also you can set the future value. Yes, it says you can set the future value as yeah. So in this case, it's very interesting. You can put 19,000. Yes, that's right. So, and then if you put CPT, give you yeah. So in this case, is already put the future value there as well, which means that you can basically I don't know what's happened here. So let's clear everything again. Yeah. So future value. You can already set it there. That's interesting. So yes, you can put it there, set it there, and then 930 is your payment, right? So payment, and now 3% compounded and 24, and P over I is 12. Quit and CPT present value. Okay, so what did they do? They did here that they presume the future value. That's pretty good actually. The future value, because the future value here is just your residual. Okay, so the residual. So as you said here, the lease, right? So let's go to the term for lease, right? So lease. Okay, so lease is you put the down payment. You pay for your car for 3 years. At the end of your payment, you will ask for residual. You already paid. You can either pay the residual and get your car, or you say no, I'm not going to pay residual. Just you can get your car back. Okay, you give your car back to the basically the lesser, like the one who leads. Okay. So that's basically lease amount. And now in the calculator you can also set the basically like this. So in the F future value can be the residual. Can be residual, and then you can set it here, right? So the residual, and then it calculate the present value for this residual and for your annuity at the same time. So the present value which calculate for you is going to be the present value for the residual and for the annuity. So all together, some of them together. Okay. So that's how it's going to be calculated. So in my mind, I was thinking the other way you can do this is going to be you calculate the annuity first, and then you clear it up. So for annuity, we can basically put the future value 0, right? So if future value is 0, the rest is going to be the same, and then calculate the present value for annuity is 21,691. I will save it, store it at number 1. Okay, and now I will clear everything here. Yeah. Make sure recall number 1 is still there. Yeah. So I will let me just clear again. And now I will do it as a ordinary investment. So 19,000 is a future value. We want to know what's the present value for that, right? So 19,000 is going to be your future value, right? And now we don't have any payment. Okay, ordinary investment. We already know how to do it, right? I over y is 3. N is 24. P over y is 12. Already there. So and do CPT present value is going to be with negative sign. So it's going to be 17,000, right? So 17,894. That's going to be basically present value for 19,000, right? That we calculated here. Right? 17,894, right? So for 19,000, so it's going to be this, and then I add this number with recall 1, and it's going to be 39,586. So either you can do that, or you just put the future value as a residual money. So that's the function calculator, which is pretty interesting. So calculator give you this option that you basically use this functionality that you basically can put your future value as a residual amount. That residual amount. If this is like a lease, right? So if you work for a car dealership or whatever, or if you want to calculate the lease, you can just use your calculator for this, right? So you just go put the future value as a residual amount and find what the present value is going to be, right?
Professor, you added the annuity with what?
you add the annuity with the residual present value of residual. Okay, let's go here, right? So let's go here and see. So this is a down payment, and then you have to find the present value for this annuity, right? So to add it to down payment, and also you have to find the present value for that residual, which is $19,000, right? You have to find what's the present value for that, because you paid in 2 years. You want to know what's the today value of that 2 years of $19,000 in 2 years. How much is going to be present value for that? Because if you put money in the bank, after 2 years it becomes $19,000. You want to know what's the today value, okay? So you add this number to this number to this number, give you the whole cost, okay, of the car, yeah. So you can do it separately. Separately, you can find the present value of annuity with the calculator, and also you can find present value of the $19,000 with the calculator, okay, and then add them together. Or you can just combine both of them in the calculator. How you put just the future value as a residual value, 19,000 as a residual value. You don't put the future value as 0 and find the present value. You just put the $19,000. Okay. Make sure you put the negative sign, because it's basically you have to pay. When you have to pay, means they have to be negative sign. When you receive, then you put positive sign. Okay. Payment, you have to pay, negative sign. Future value, you have to pay, negative sign. Okay. When you receive the money, then you put positive sign. Okay. So then you put this as a future value, because you want to pay that residual. You put that payment there, and then you calculate both at the same time. Calculate both the present value for that future value and also the present value for your annuity, and sum them together. So that's what calculator does. Okay. You understand this, guys?
Professor, can I ask, why don't they just pay? Why don't we just calculate the total payment, like for the lease bit, like $930 times by 2 years, like what, every month, like 24 payment times by 930.
Yeah, but that's okay. So that's the problem is that we have to go back to the beginning of the lessons, right? So we talk about this, like what's the present value? Because the $930 you paid every month, right? So if you paid $930 today, if you paid $930 2 months, it's different. That the $930 does not have the same value of $930 in 2 years, right? Because you have interest, right? So $930 today, in 2 years with 3% compounded monthly, is going to be $1,000, $1,050, right? So the value of the money change over time, okay? And this is annuity, right? Annuity basically is something which you have. Your question is very basic, okay? Is that Vivian, or who is that? Vivian, or?
Yes.
Yeah. So your question is very basic, okay? So your question is very basic. We discussed this in last week's session, right? When we discussed annuity and what is annuity, okay? Your question is very, very basic. So it's just it means that you're still basically struggling to understand what the annuity means, okay? The total number of payment you pay here, the total number of payment that you are to pay, right? So, but your value of the money is change over time. So $930 today is very different than $930 at 2 years, because you have interest, right? So, and then you want to find how much payment at today value you pay for that car, okay? Today value, okay? So you need to shift everything. Let me go back to this, okay? You see, each payment you pay, okay? So, okay, this is the future value. Let's see the present value. So, okay, so each payment you pay over time has a present value meaning. Okay, so the payment you pay at the first month at present value is PMT 1 plus I. Payment value at second month present value is going to be 1 plus I minus 2. Present value of your payment in future has your any payment you do in the future has a present value meaning or present value value. Okay, so it has a
Yeah.
present value. Okay, and then you have to add all these present values for all the payments to get the present value for the due annuity. Okay.
Basically, the I guess amount will change because of the interest is going to be added.
Exactly. That's because of interest. If there is no interest, you're right. If interest was 0, you're right. So why we don't just do 24 times multiplied by the payment, like 900 whatever. Okay. If there is no interest, you're totally right, because you do this payment, you add them together, it's going to be number of payment you pay. But since you have interest, your money doesn't have the same value as today. So 930 bucks in 2 years is going to be like 850 bucks today, right? Because of interest. So now we need to know every payment's what's going to be the value for today, and then add them together to find the present value for due annuity, right? And the equation is going to be this. If you add them together, it's going to be very long. For each payment, we need to know what's the value, and then calculate. It's going to be 20 terms, and you have to. The mathematician makes our life very easy. They find one compact equation for that. It's going to be this equation, the compact equation for all the series of these.
So she can just pay for the present value amount that you calculate at the beginning instead of pay.
Yes. Exactly. Instead of paying annuity. Yes.
Right.
Yeah. So, in other words, you can get the loan from the bank, and then you do this payment, and the value of the loan from the bank is going to be this payment. Okay. So basically, you get a loan. You get a $1,000 loan from bank. Okay. Every month you pay $100. Okay. $100, and then you get that. Okay. So I did this last week, but I just don't want to repeat it again. But yeah, so you just go to the last week basically link, and then you find. So you pay the $1,000 you get from bank every month is going to be interest on it, but you pay it, and then it's going to be another interest, and you pay it. You're going to be another interest. You're going to pay it, and until the end of the period. Your last payment is going to be wiped. So basically, and that the loan to get it from bank, the present value. Your present value of annuity is going to be the loan you get from bank. Okay.
So are you saying that if you don't choose annuity, if you have if you just pay, if you have money to pay the present value like at once, you won't have to pay for interest.
That's right. Exactly. You don't have to pay for interest. Yes.
So we are calculating this if she does want to pay the interest. I mean,
yes.
The $930 per
That's
month.
right. That's right. Yes.
So we are calculating like for the situation, like for her, like the person that who like the second options for purchasing the car, and I don't think she has the money. If she doesn't choose the one-off payment for the car, like the 50,000 something, because she doesn't have money, and then
exactly. That's the case, right? That's brutality of the financial system, right? When you don't have the money, then you have to make a payment. So you have to pay much more money, right? That's why always buying cash is the best option. You buy your car in cash, you buy your house in cash. You save a lot of money. Yeah.
So if she has the money, I mean, she has to pay for $930 per month because she doesn't have the money.
Exactly.
And that would be the actual amount she paid. Like
Yes.
$930 for
Yes.
2 years per month.
Yes.
So we should add that, like, to compare to the 51,000. I mean 5,100.
Yeah, so 5,100 is going to be present value, right? But $930, as I said, is every month. You paid every month, means every month.
Because we are,
yeah.
Because as from our understanding, we are comparing, like we're comparing. So, $5,100 compared to what she actually paid, not like the present value, because she actually didn't choose the present value option.
Yes.
She would choose that if she has the money.
Of course, not the present value. So she has to pay $67,000 for the vehicle, while she could just pay $51,000 and buy it, but because she didn't have money, she has to pay $67,000. Yeah, so $27,000 right now because she has money for that right now if she paid, but she doesn't have the rest. So now that she has to go through the payment, and at the end of the 2 years also have to pay $19,000, right?
Yeah, but does she have to pay for the $19,000? Right.
At the end is she has an option whether she wants to get rid of the vehicle, she say no, I don't want this vehicle anymore, and give it back to leaser, or pay $19,000 to buy the vehicle. So she has options. That's basically the lease options, right? So, but if you presume that she buy it at the end of the period, which generally is most of the cases like that. Most people after lease, some people after lease they buy the vehicle. Some people get rid of the vehicle because the vehicles are like 3-4 years old and start to get the maintenance, and then they buy a new one. But in case if she want to buy it, she has to pay $19,000.
Oh.
Yeah.
Yeah, but does she actually pay for $930 per month for 2 years?
Yes.
That's the question.
Yes.
So that would be, we actually use that to compare to the other option, right? Not the present value, because that's what we actually need to pay.
Yeah, that's right. Yeah, that's right.
So why do we calculate the other way? Like,
which other way?
But why do we calculate present value if we, like, if we're comparing with the thing we actually pay, the amount?
No. As I said, we need to find the present value for this annuity, right? So she paid. I don't know what's this. She paid every $930 every month. We need to find what's the present value for this annuity. With $930, what's the present value for this? Okay, and then add it to this and add it to present value for $19,000. $19,000 is also in 2 years, right?
What is the present value for? Like, she doesn't pay for the present value. She pay for.
Professor, would that mean that the present value would be the amount that if she is not going to lease but instead decide to purchase, that would be the present value?
Definitely. So yeah. So if she wants to purchase it right away without going to the lease, that's going to be present value. Yes, that's right. So in other words, if she purchases it, okay, if she purchases it and then she doesn't have any money, then she has to go through the annuity. That's going to be present value. Yeah. Yes, the amount of purchase, the amount of loan at the beginning, the present value. Yes, that's right.
But actually, the $930 times by 24 is actually comes out from my bank account.
Yes,
not the present. But at the end, not the present. That's the amount.
No, it's not. It's not the present value. So $930 multiplied by 24
It's the actual amount.
It's the actual money that you paid, but it's not present value. It's not present value. The present value is the actual money you borrowed. You borrowed to pay back with this annuity. Okay.
So we compare. Are we comparing the actual? Are we not comparing the actual amount that we pay to the value of the car?
No, we're not comparing that. No, because this is the
Comparing
annuity you pay.
the
Because
present value.
yes, because you have interest, right? If you don't have interest, yes, $930 multiplied by 12 multiplied by 2 is going to be the money, your present value, your future value, everything value. It's going to be that payment. Your payment is going to be that one, okay? But as long as you get interest less than zero, more than zero, then you're looking at the present value. You're looking at annuity, and then you have to find the present value for this. You understand? Because your payments, they're not worth anymore. Because $930 is not $930 anymore. Let me just go to that. Where is that? Yeah. Because now you're $930. Let me go that. Where is that? Yes, here. So your $930 2 years from now is not $930 today, because your $930 has to be multiplied by 1 plus I, which is your interest rate power of -3. So that's
if I only
it loses the value. It loses the value when your $1,000 today, comparing your $1,000 today with the $1,000 15 years ago when I started at UBC. Okay, when I started at UBC, my rent was $800 for 1-bedroom apartment in downtown Vancouver. Right now, that apartment is like $2,600, $2,700. Okay, my money today is my $1,000 today is very different than 10 years ago. Okay, so that's the same thing here. So you do $930 2 years from now, doesn't worth today. So you have to calculate how much is today. I don't know what's wrong with this. You have to calculate how much is today, right? So you have to use this equation.
I think she's not very smart if she only look at the present value, and then actually pay for $930 times by 24, because present value is less than the amount.
Yes, that's what you can do, right? So you can't do much about it, right? So because she doesn't have money. If she has money, she paid already. She paid like $51,500. That's even better than this $67,000, right? So she paid this one, and she doesn't need to pay anything more. So now she's paying for this, and also pay interest on top of it. So it's not just this. It's not just $67,000, right? She's paying much more than that. She's paying 27 plus this plus this. So 27 plus 930 multiplied by 24 plus 19,000, which is going to be around, almost $100,000. Almost $100,000 for the car. Okay.
What if the value is well stated, is well like presented, and telling you, why is it telling you about the interest? Because obviously $9,000 is there, is already given to you. You are gonna be charged with that amount. So they are freeing you from calculating the interest. So would that be the interest, the amount that we take into consideration?
Yes. So the present value of your annuity is basically what you borrowed from lender. Okay, and then with this scheme, with this strategy of paying monthly, you wipe that payment out. Okay, so you start to pay until your last payment. You basically wipe that payment out. Okay, so basically the present value of the annuity is what you borrowed at the first place. What you borrowed at the first place.
Yeah, but she actually paid for $19,000 at the end. if she wants to buy the car.
Yeah, at the end she paid, and then it's going to be interest, right? So the whole thing that she paid minus the price of the car is going to be the interest that she paid, right? Yeah.
Yeah, we compare option is like is better. So.
Oh, definitely, the option one is much better. Yeah. All right, guys. So it's getting late, so we need to discuss one more topic. So we're gonna take 15 minutes break, and then we come back at 1:35. Okay. The next part is not gonna be that long, so it's gonna be another half an hour or something like that. Okay. All right, guys. Talk to you in 15 minutes. All right, guys, welcome back. We're gonna start in a minute. So Vivian, did you get it, or you still need some help?
Yeah, Professor, my mistake. Yeah, if she doesn't have the money, she will have to pay for the interest. It's her, it's
Yes.
her responsibility.
That's right. Yes,
Yeah.
that's right. Yes.
Yeah.
All
So
right.
that part doesn't count.
Yeah, that's right. Yeah. Yeah. So yeah, there are some study learning group as well, right? So and also some supporting other supporting materials for you. If you're interested in this, you can just go to that study learning group that I think Cherry came a few weeks ago and introduced herself, right? So she also can help you guys if you have difficulty with the course, if you want to understand the concept more, if you want to practice it more, if you have something unclear, you can also go that's a learning group and also student advisors, right? So these are important for you guys to basically get a good mark from for the course. Okay. The concept is a little bit more complicated, but still is very manageable. I would say it's not too hard, right? It's pretty simple concept, simple formulation. Also, calculator help you guys a lot for understanding this. Okay. I'm going to share my screen now for the last part of our session.
Professor, I might need to ask you to show me how to change it from end to beginning again.
Sure, yeah, I will do that right now. Let's go to calculator. Do you see the calculator now?
Yeah.
All right, so second PMT,
yeah.
Second PMT, begin.
Yeah.
And if you want to change it, second.
It just doesn't change. I don't know why.
Second.
Enter.
Second enter.
Right.
Yeah, and begin, and begin, and begin. Begin and begin. Second quit. And if you quit and begin, you see this begin, BGN on top of the calculator.
Yes.
Okay. And if you don't like it, you want to set at end, quit, you don't see anything because end is already default. The default is end. Default is ordinary. Default is ordinary annuity, and that's do annuity is going to be begin. So because we are working with do annuity right now, so I'm going to say that begin so that I don't forget it. So it's a begin. Okay. All right, so let's do the last part of the course. That's do general, right? So the do general is going to be last part of our course. So future value and present value of a do general, basically annuity. Okay. So the equation are the same. So it's the same as do simple annuity. The only thing is different is the interest rate compounding period is different than your payment compounding period, which you need to use the same equation, right? So the equation of this equation, C number of compounding period per year divided by number of payment per year. So this is compounding frequency divided by number of payment per year. With this C, we transfer or convert the interest rate, which is not compounded based on the period that the payment to the interest rate, which is basically compounded the same period of the payment period. Okay, so this is the interest rate which is not the same compounding period as the payment period to the interest rate which is compounded with the same period as a payment period. Okay, so that's the only thing which you need to change in the equation. We need to basically find I2 based on the I. So C and the C is compounding frequency divided by number of payment per year. Okay, and then the rest is going to be the same. So we use that. After we find that I2, we'll find the future value for do annuity based on the equation of the do annuity, which is going to be the equation for for ordinary annuity multiplied by 1 plus I2, and also present value, same equation. Okay, so the only thing which we need to change from simple to general is just using that equation for I2, which is here. Yeah. So in a general due annuity, payments are made at the beginning of each payment period, and the compounding period is not equal to the payment period. Okay. So to calculate the equivalent periodic interest rate per payment period I2, we first need to find I2, and after we find I2 and as defined I2, the value of I2 can be submitted in the simple annuity due form formula to get the future value and present value of general value. Okay, so very simple. So the equation are the same as equation are the same. The only thing which changes is you need to find I2, because you can't use that I anymore, because the I compounding period is different than your payment period. So which of the following statement best describes general due annuity? Payment made are made at the end of the period, so this means ordinary, so it's not due. Payment are made at the beginning of the period, this is due, and the compounding period is different. This is general B, a B. Yeah, compounding period is different than the payment period. That's a B. Okay. Last invested 3,500 at the beginning of every year for 8 years in a software company that assured him an interest rate of 5.4% compound quarterly on his investment. How much did he invest in total in the business? Okay. Okay. So beginning means due, and compound quarterly, but he is spent every year, right? So it's the interest rate compound quarterly, right? So it means compounding frequency is 4, but he is spending only every year. So his payment period is 1 year. His payment period is 1 year, but his compounding period is 3 months. His compounding period is 3 months. His payment period is 1 year. So this is general. Beginning is due. Okay, so due general. So you need to use due general annuity formulation, right? First of all, since it's general, we need to find I2. Don't forget, when it's general, either ordinary or due annuity, we first need to find I2. Okay, don't forget I2 general. Okay, and I2 is equal to 1 plus I power of C minus 1, right? First find C. Okay, what's the C? Oh, first of all, let's do the other stuff. So how many payments he made per year is 8 payment. How many total payment is 8 payment, right? So okay, so how much did he invest in the business? Yeah, for sure. How much? The question, first of all, how much did he invest in the business? So of course, so he paid $3,500, 8 payments, so it's going to be $28,000 in investment in the business. Okay, so how much the accumulated value of this investment? Okay, so yeah, it's very important, guys. How much he invest and how much the accumulated value of his investment, right? So he invests this much, like he invests 3,500 multiplied by 8, so it's going to be $28,000. Okay, but how much the accumulated value of his investment? This is the future value. Okay, accumulated value, or interest value, or future value, or basically total amount of money, something like that. So these are accumulated value. Okay, so accumulated value is going to be future value. So now you need to basically use the equation. Okay, so this is general due. First we need to for I2. I2, as I said, is going to be 1 plus I power of C minus 1. C in this case is compounding frequency, which is going to be 4, right? Divided by number of payment per year, which is going to be 1, right? So number of payment per year is 1, and compounding frequency is 4, right? Because it's compounding quarterly. So 4 divided by 1. 4 divided by 1. This is C. Okay. Calculate that. It's going to be I2. Now we need to use the future value formulation for due general annuity, right? So it's going to be PMT 1 plus I2 power of n minus 1 divided by I2 divided by 1 by 1 plus 1 plus I2, and now we need to calculate this. Okay. let's do this together. Okay, so let's do this in calculator together, and let's clear everything. Let's do this together. First, find I2. I2 is equal to 1 plus 1.0135 power of 4 minus 1. 1.135 power of 4 minus 1. That's I2. I will store it at 1 because this is, I need the whole number. Okay. And now I want to calculate this. This is I2, this is I2, this is I2. So 1 plus I2 power of 8. So I already stored I2 in number 1. Okay. 1 plus recall 1. This. Okay. 1 plus I2 power of 8. Power of 8 equal to, that's going to be this guy, minus 1 equal to this guy. Okay, so it's going to be numerator divided by denominator, which is I2, divided by recall 1. I2, I already put the I2 in the recall 1, right? So 9.7. So it's going to be the whole guy. Okay, so I store this guy at number 2. Okay, I don't want to lose it. So 1 plus I2, 1 plus recall 1, I2, this is this guy, multiply by the one which I store at number 2, right? Multiply by recall 2 equal to, this is this guy, and multiply by 3,500. Multiply by 3,500. Equal to 35,930. Okay. So that's going to be accumulated value. Okay. So your question, right, Vivian, now see this, he invested $28,000, right? But that's not really $28,000. He already have in bank $35,000, right? Because he got interest. Okay, because got interest. So basically, his money in the bank now is $35,000, although he paid $28,000, right? He already paid $28,000, but it's not $28,000 anymore because as you can see, the interest goes on his money, and he has $35,000. Okay.
What's the value she invests?
The value she invests, is $28,000, right? So she has invested $3,500 every year for 8 years. So 8 multiplied by 3,500 is $28,000, right? So he put the money to $28,000 in the bank, but at the end of 8 years, we see, oh my God, she got $35,000, right? So because there is interest on each of his payments.
Yeah, like at the end of every year for 8 years. Yeah.
Yes. Yeah. All right. What was the interest earned over the period? Yeah, that's another question. So how much interest he earned? The money he has in the bank at the end minus the money she put in the bank. Okay. So that's interest. So he earned $8,000 interest, almost $7,930. Okay. And then you want to do it in calculator mode? Let's do it in calculator mode. This is more fun. This is the most difficult part of this. Let's do in calculator. So what was the accumulated value of investment, which is easy, 3,500 multiplied by 8. What was the interest over the period? Okay. All right. So let's do it in calculator. Clear this. Sorry. So clear this. All right. Invested 3,500 at the beginning of every year. Okay, so 3,500, a negative sign, invested, and now 8 years every year. So n is going to be 8, right? So every year number of payments is going to be 8. So 8 is number of payments. And then interest is 5.4%, 5.4% interest rate. Yeah. So now we know the payment. We want to do the present value is 0, right? So because because we want to find what's the future value. So we set everything right here. We need to go to the second P over Y. Payment over a year. How many payment per year? One payment per year. One set. So and then compounding per year. Compounding frequency. What's the compounding frequency? 4, right? Compounding quarterly. 4. Yeah. And then quit. Now CPT future value 35,930. Yeah, 35,930. Yeah, total amount invested is 28,000 minus this is going to be interest. Yeah. Any question, guys? So basically in calculator, make sure it's begin when you're working with do at beginning. Okay, make sure it's begin, and then for general do annuity, the only difference is just you go to P over Y. P over Y is different than C over Y. Okay, so P over Y and C over Y is different. So that's the only thing that's different in do annuity. The rest is going to be the same. And quick. Okay. All right. So another question. I give you guys a few minutes for this as well. I'll give you guys 5 minutes for this. Rima inherited her husband's money, which provided her with 6,750 at the beginning of every month for 25 years. Okay. If the interest on the saving account was 4.8% compounded semi-annually, what was the total amount of money she inherited? Okay. Round your answer to the nearest $100. Okay. The nearest $100. Okay. When you round your answer to nearest $100 means has to be 0, 0, 0, 0 like here. So this is not right. Already you know that it's not right. Okay. So she inherited the money, and now she's taking money from that, right? So inherited the money at the first place, and now she's taking money out of it for 25 years until it's over. Okay. So the money she inherited is going to be basically present value. Okay. So now she's inherited and she's taking out of it every month. Okay. For 25 years. So basically what they were inherited is going to be the present value. This is a present value problem. Okay, guys, that's very important. Okay, so let's give you 5 minutes for this. All right, so we got two answers from Ka and Priyanshi. Okay, let's see which one is right. So, all right, D is right. Who is this? D. Ka. Okay, so what? So, yeah, A is right, Priyanshi. But it said you have to look at the question. Round your answer to the nearest $100. Yeah, this is the right answer. You're right, but you need to round it to nearest $100. Yeah, so that's a tricky part of the question. Okay. All right, so let's solve this question. Okay. Okay. First, we need to find which kind of annuity is this, right? So first, the payment has been done at the beginning of the month. So beginning means it's due, right? It's due annuity. And then which kind of annuity is this? 4.8% component semi-annually, right? So, and she basically paying monthly. So the compounding interest rate is different than the payment period. So this is general. So do general, right? So you need to use do general equations, okay? So for that, first of all, it's general, right? If it's general, immediately you have to calculate I2, right? I2. You have I, which is going to be 4.8 divided by 2, right? And then you find I2, which is basically as I said, this is a present value, right? So this is a present value problem. So why is it present value? Because she has a money at the beginning, and then she's basically taking out of it for 25 years. Okay, so we want to know what's the money at the beginning. Okay, what was the money at the beginning that she's taking out every 5 up to 25 years? She take every month. Okay, so that's a present value. Okay, and now as we said, so we need to find basically I. Okay. We need to find I, we need to find N, we need to find C because it's general annuity, right? And then use the equation of I2, right? So we need to find I2 first. I2 is going to be 1 plus I, which is basically this guy, 4.8 divided by 2 divided by 100, right? So this is I. Power of C, which is compounding frequency for your interest rate, which is 2, divided by number of payment per year, which is 12. Compounding frequency divided by number of payment per year. Okay, minus 1. That's going to be this one, and then use this equation for calculation PV due, right? So if you put the stuff in this, then let's do it together. First, we need to find I2. Let me find I2. All right, let's go there. Find I2. It's 1.025 power of 2 over 12, right? So 1.024 power of, okay, so it's not as tricky, but 2 over 12 is 1 over 6, right? So you need to put parentheses here, 1 divided by 6, parentheses close, this kind, okay? If you're uncomfortable with this, you can do this. You can do this base, you store this and you store that, and then you put this guy power of this guy. Okay, let's do that the other way. 1.025, 1.025, sorry, store at number 1, 2 over 12, 2 over 12, store at number 2. Oh, sorry, 2 over 12 equal to, and then store at number 2. And now number 1 power of number 2, recall number 1 power of, recall number 2 equal to this, okay? And then minus 1 equal to this. This is going to be I2. So store at number 1, okay? So I store at number 1. Now we go to this this equation, okay? So why number 1 is different than the other one? Oh, maybe make some mistake. So let's see why this is different. So 1.0, sorry, recall number 1. Oops, sorry, we just make it. All right, so 1.024 power of 2 divided by 12 close equal to -1. Okay, so this is. So what did we do mistake? Why the other way was not right? Okay, so let's okay 1.02. Let's do 1.024. Store at number 1. 2/12. 2 divided by 12 equal to store at number 2. So recall number 1 power of recall number 2 equal to -1 equal to, okay, so this is right. So it's, I don't know why what was wrong. So store number 1. So this is I2, right? This is I2. Now we need to calculate this guy, okay, the big guy, okay. So we start from this most interior one. 1 plus I2 power of -300. 1 plus recall 1. This is I2 power of 300 negative. Correct? This one. This is going to be. It's going to be this guy. Yeah. 1 minus this guy. So I store this. Don't forget, you have in slot 1 you have I2. You don't want to touch it. You store it to number 2. Okay. So 1 minus recall 2. It's going to be this guy. So it's going to be the denominator divided by I2 divided by recall number 1. Okay. 175. So that's going to be the whole thing. This guy, the whole thing. Okay. This has to be multiplied by open parenthesis 1 plus recall 1 I2 close parenthesis equal to this. Okay, so that's going to be the whole thing multiplied by PMT, which is 6570 multiplied by 6750. Sorry. But yeah, so 1.11 this. Okay, but round to the nearest 100. Okay, so nearest 100 is going to be this guy. Okay, so the D is right. Okay, so if you want to do in the calculator way, okay, so if you want to do in calculator way, let's clear everything. Calculator method, right? So 6750 beginning of every month for 25 years. 6750 is going to be your negative sign. It's going to be your payment. Yeah. Oh, she's receiving that. Okay. Since she's receiving the money, then you don't need to put negative there. So you put a positive. Okay. And now the future value for this is 0, right? Because we want to calculate the present value. So after 25 years, she has nothing in the account. Okay. That's how you say. That's how you set the future value, right? After 25 years, she has 0 in the account. After 25 years, she get all the money out. Okay, so that's a future value. So it's going to be 0 in the account. Okay, and now let's do the rest. So you have the payment. We set the payment. You have the future value. We want to know what's the present value. That I over Y. What's I over Y? 4.8%. 4.8% is I over Y. And now how many payments? How many total payments? It's going to be every month for 25 years. 25 multiplied by 12, right? So 300. So 300 is going to be number of payment, all right? So we set everything right now. Then now we have to go to P over Y and Y over Y. P over Y. Payment per year. It's going to be 12, right? 12 payment per year, right? And then compounding frequency per year. Compounding semi-annually, which is going to be 2. 2 is going to be this, okay? And then quit. Okay, so now we have this. You have everything set. So second present value. Sorry guys. Sorry. Second quit. Second present value. Oh my God, what did I? No, sorry guys. CPT present value. I'm sorry guys. CPT present value. So $1 million, 1.8. That's what we calculate, right? And it's a negative sign. You get a little negative sign in front of it because it said that's it's already in your account. So, and then you have to round it to nearest 100, which is going to be this guy. Okay, that's it. So, so this is basically the way we calculate the present value for due general annuity. Okay.
Hi, Professor.
Yes.
Just wondering, is there a definition of C how do you explain C?
Oh, C.
Yeah, I'll just
C.
no. I just want the name of it.
C is just there's no term as C. There's no, basically they don't say what the C is. So right, so C is
So what's C?
C is number of compounding period per year divided by number of payment per year. There's no okay, so they don't call it anything. They call it C. Okay, the number of compounding period per year divided periods per payment period. So C is the number of compounding periods per payment period. So that's what they call it. So
Yeah, but is it the same formula as
yes,
calculating different rates?
Yes, definitely the same. Yeah, so equivalent rate, right? So you have the rates, but it's compounded differently than the rate that you want to be compounded, right? So you compound it differently than your payment period. So you need to find the new rate, which is compounded the same period as your payment period. So that's equivalent rate. That's this rate is equivalent to this rate. So how do you do it? So the new rate is going to be the old rate power of C. So C is going to be number of compound period divided by payment period. Yeah.
So according to like a few lessons back, the formula is for C is
yes,
M1
M1 divided by M2. Yes, that's right. So yeah, M1 divided M. What's M1 here? M1 is
number of
basically
compounding periods.
yes, compounding frequency
Yeah.
for the first one. And what's M2 here? Compounding frequency for your new one, right? So yeah, so it's compounding frequency divided by compounding frequency. That's right. Yes, the same equation. Same equation. Compounding frequency divided by compounding frequency. You want to change from the old compounding frequency to new compounding frequency. Your old compounding frequency doesn't match. Now you have to fix it to make it the new compounding frequency, which matches. Yeah.
I'll just a bit confused. Which one goes to the top? Which one goes to the bottom? If I don't remember the formula.
Yes.
Like
the one which is going to the top one is the one which is related to the first guy, the one inside.
Yeah.
Bottom one is the one which is related to this guy, I2. Top is for the I, bottom is for I2.
So the bottom one, I2 is
for I2, yes.
We have the aim of like the number of payment decided the aim for I2.
Yes. So bottom is I2, top is I1.
I'll just remember the formula.
Okay. Sounds good, Vivian. You're working very hard. I'm proud of you.
I'm proud of myself too.
All right. So, any other question, guys? Any other question? All right. You need a lot of practice, guys. You need to go to lab and lessons. Yeah. So just go to lab and lessons and do a lesson. I believe you can do right now NSS. Let's go. I think make sure that you finish the lab 5 for sure today, right? February 26th is going to be your deadline for this. Okay, so ordinary, simple, ordinary, general. You see it? Can you see my face? My can you see my this one? Can you see it? You see it, right? So lesson 5. Yeah. All right. So you see this, right, guys? I'm sorry, guys. I lost you for a second. Can you see this this page, lesson 5 and lab 5? Can you see it, the web page?
Yes, Professor.
Oh yeah, correct. All right. So I lost you for a second. I thought you lost connection. So, all right. So you make sure to see this. We do this ordinary simple or ordinary general. So this is for last week. So you make sure you finish this, and I believe you can do this as well, right? So lesson 6, right? So you have until March 12, but you can do it now. So simple annuity do, general annuity do that. So you can do this as well. So you can do 5 and 6. And then let's see what the 7 is. No, 7 is not. So yeah, so you can do 5 and 6 by now. And you have also a study week next week, right? So you can basically finish lessons and labs, and you make yourself ready for the other week. So next week we don't have any class, guys. So next week we don't have any class anymore, and basically it's a study week. So, and I will see you guys 2 weeks from now. So if you don't have any questions, do you have any question, guys? All right. No.
Yeah, I was just wondering, why not choosing I1 instead of I2?
We use
Oh.
I1, right? This is I1. This is I1 already, right? The first I is I1. Yeah. The first I is I1,
Yeah.
right?
Yes.
Yes. All right. Okay. All right, Vivian. First I is I1. Okay. And I2 is the second I. Okay. All right. So any other question, guys? All right. No question means everyone is good. So just make sure you finish lesson and lab 5 and 6, guys, before the deadline. The deadline for 5 is like 4 days from now, guys. Make sure you finish that, and then see you guys 2 weeks from now. Okay. All right, guys. Have a good study week. So. Yeah. All right. Bye.
Bye.
Bye.